By the end of this video, you will learn how to use signed numbers to represent movement or time. This is the lesson walkthrough video. You may also go to Unit 5 Video Support Introduction videos to see short videos on our topic. Please pause this video while you attempt the warm-up. After attempting the warm-up, please unpause to review your answers. Distance equals rate times time is an equation you may have found on your math reference sheet. We can put this into a table, or we can also use a fact-family triangle that relates multiplication and division. So distance equals rate times time. So rate times time equals distance. That means distance divided by rate equals time, and distance divided by time equals rate. 120 miles per hour is a rate, and 3 hours is a time. So we're going to multiply those to find our distance. You can also see this in a ratio table that compares miles to hours. 120 miles per hour and looking for how many miles in 3 hours. We can either use our scale factor to go from hours to hours and miles to miles. So 1 times 3 equals 3. So we would multiply 120 times 3. You can also use your constant of proportionality going from hours to miles. So 1 times 120 is 120. 3 times 120 is 360. So no matter which method you choose, you should get 360 miles. So 120 miles per hour times 3 hours is 360 miles. For problem number 2, we have 6 miles in 4 minutes. So we have a distance and a time, and according to our fact family, distance divided by time equals our rate. So we're going to do 6 divided by 4 gives us 1.5 miles per minute. You can also put that into a ratio table if you needed some help to solve it. So I'm going to erase my parts over here so we can see it. All right, so we have miles and minutes. We have 6 miles in 4 minutes, and we know that our rate is going to be per 1 minute. So following that method, we do 6 divided by 4, just like we did 4 divided by 4 to get to 1. And we get 1.5 miles in 1 minute. So 1.5 miles per minute is the rate for number 2. On problem number 3, we have a constant speed of 50 miles per hour, which is a rate because it's per hour. And how long does it take the car to go 200 miles, which is a distance? When we have distance and rate, we do distance divided by rate according to our fact family triangle. So we're going to do 200 divided by 50 equals 4 hours. You can also put that into a proportional relationship table or a ratio table to help you solve. Going left, going right. Use the number line to help you fill out the table. Then write an expression to represent the ending position that uses the starting position, the speed, and the time. The first row is done for you. Now looking at our number line, you can see that when we are moving right on our number line, we are going in a positive direction. And when we are going left on our number line, we are going in a negative direction. So in our table, any directions that are right are going to be positive changes, and any of our directions that are going left are going to be negative changes. You may notice in your table that because distance equals rate times time, they took the speed and the time and multiplied them together and then added them to the starting position to get their ending position. All of these start at 0, so all the way down the table, our expression is going to start with 0. And then you'll be adding how far they went. Okay, so on the second row, it says we went left 4 units per second for 6 seconds. So because we're going left, we're going to go a negative 4 units per second. So we're going to do -4 times 6. -4 times 6 is -24. Adding that to 0 puts us at -24 for our ending position. You can see in the table that when I moved to the right and had a positive time, my ending positions were positive. But when I moved to the left, my ending positions were negative. That's because a positive times a positive is a positive, and a negative times a positive is a negative. Number 2 says, how can you see the direction of movement in the expression? So if you have a negative, it's moving to the left. So left is negative. You can see that moving to the left is negative and moving to the right is positive. Velocity is the speed of something in a given direction. A traffic safety engineer was studying travel patterns along a highway. She set up a camera and recorded the speed and direction of cars and trucks that passed by the camera. Positions to the east of the camera are positive and to the west are negative. This means that at 0 is where they are passing the camera. Vehicles that are traveling towards the east have a positive velocity. Vehicles traveling towards the west have a negative velocity. Because positive velocities are east and negative velocities are west, we can identify which direction our cars or vehicles are going based on their velocity. So going 25 meters to the positive is going to be east, a negative is west, a positive is east, a negative is west, and another positive is east. Because we are comparing the time to passing the camera, and the camera was identified as 0, then our ending position is going to be 0 plus the distance. And the distance is going to be rate, which is a velocity, times time. That's why in the first row, we have the rate times the time equals the ending position. So we're going to take our velocities times our time and get our ending positions. So in row number 2, we have -20 times 30 equals, now we have a positive and a negative, so we're going to end up with a negative answer. -20 times 30 is equal to -600. To help you see this, let's take a look at the number line I've drawn on the top of this screen. So when we are going in a positive direction, a positive amount of times, our multiplication will be positive. When I'm going to the negative, a positive number of times, I end up at a negative because I'm repeatedly adding negatives, which puts me more in the negative. Please pause your screen at this time and take a look at your answers and see if they match mine. If a car is traveling east when it passes the camera, will its position be positive or negative 60 seconds after it passes the camera? If we multiply two positive numbers, is the result positive or negative? As the car is moving east, it's moving towards the positive direction, And since we're talking about after the camera, which is at 0, then we're going to be at a positive position. When we multiply two positive numbers, the result is positive. If a car is traveling west when it passes the camera, will its position be positive or negative 60 seconds after it passes the camera? If we multiply a positive and a negative number, is the result positive or negative? So after we pass the camera, which is at 0, if we're traveling west, we're traveling the negative direction. This means after it passes the camera, we are going to be at a negative position. If we multiply a positive and a negative, the result is negative. Backwards in time. A traffic safety engineer was studying travel patterns along a highway. She set up a camera and recorded the speed and direction of cars and trucks that passed by the camera. Positions to the east of the camera are positive and to the west are negative. So 0 is going to be where our camera is. Positive numbers are to the east, negative numbers are to the west. Here are some positions and times for one car. You can see that as the time increases, our position becomes more positive. So in what direction is the car moving? Please pause this video and make an attempt on this task before unpausing. As the seconds increase, we are becoming more positive. This means that the direction the car is moving is east. The velocity is a speed in a certain direction. So we already know that we're going east, so we're going to be going positive. And after 1 second, they had gone 60 feet, and after 2 seconds, they had gone 120 feet. So this means that we're going 60 feet in 1 second. So its velocity is 60 feet per second. What does it mean when the time is 0? Because in our positions, 0 is where the camera is, then when they're passing the camera, that means 0 is where the camera is. Okay, so 0 is when the vehicle is in front of the camera. Looking at our number line at the top, which doesn't really have many numbers on it, but it does have directions, knowing that going to east is positive and going to west is negative in our directions, and 0 means where the camera is at, what could it mean to have a negative time? So if 0 is when the car is at the camera, then that means having a negative time is before the car reaches the camera. Here are some positions and times for a different car whose velocity is negative 50 feet per second. So going to the negative, we recall, was going towards the west. That means that this car is moving west. Okay, so when they reach the camera, that's 0 time and 0 position. Okay, so as we pass the camera 1 second, we're at negative 50. So that means going backwards in time, we have to add 50. So negative 50 plus 50 equals 0. 0 plus 50 is 50. 50 plus 50 is 100. And 100 plus 50 is 150. Something you may notice from this table is that when we take a negative velocity and we go negative in time, we end up with a positive number. This is because a negative times a negative equals a positive. In this table, we are comparing the time to passing the camera. Remember that passing the camera is at 0. happens at 0 time and at 0 position. So again, we're going to take our velocity, which is a rate in a certain direction, times our time equals our distance. And because we're adding our distance to 0, our ending position is just going to be our distance in whichever direction our velocity states that we are going. For car D, we are going negative 20 times 30. So we have a negative velocity and a positive amount of time. That means as time increases, we are going to the left. So we should end up with a negative number. So negative 20 times 30 equals negative 600. For car E, we are going a positive direction, but we're going back in time. So car E is traveling to the positive direction, but we're going back in time, and back in time makes us go the other way. So we're actually going to end up on the negative side. So negative 40 times 32 puts that before we hit the camera. We are at negative 1,280. So because we're going backwards in time, we're thinking about what happened before we hit the camera. For car F, we are negative direction, so we're going to the west, and negative time. So before we went west, we went east. Okay, so we're undoing going west. And that's why our negative times a negative is actually going to give us a positive number, because it's before hitting 0, so it's kind of like the opposite. And last but not least, we have negative 15 times negative 8. Again, we have a negative direction, which would be going to the west after we pass 0, but this is asking what about before we hit 0? So it changes our direction. So we were at positive 120 8 seconds before hitting the camera. Backwards in time. So if a car was traveling east when it passes the camera, will its position be positive or negative 60 seconds before it passes the camera? I like to use a modified number line just to kind of help me get a sense of this. So west is to the negative side, 0 is at the camera, and east is to the positive side. So the car is traveling the east direction, but it wants to know before it hits 0, is it on the positive or negative side? And you can see that before it hits 0, it's on the negative side. This means if we multiply a positive and a negative number, the result is going to be negative. If a car is traveling west when it passes the camera, will its position be positive or negative 60 seconds before it passes the camera? So again, our west is going to be to the negative side of the camera, east is to the positive side, and we are going to the west. And it says before we pass the camera, so it passes the camera at 0, before that, it's actually on the east side, which is positive. So its position would be positive before hitting 0. This means if we multiply two negative numbers, the result is positive. Lesson synthesis. We can choose a 0 point, and then positive and negative numbers can represent positions to the right or left of this 0 point. So for example, we defined east today as being our positive, and our west was negative. Sign numbers can also be used to represent speed in opposite directions. Speed in a direction is called velocity. Positive times are after a chosen zero time, and negative times are times before the chosen zero time. A positive times a positive is always a positive. So positive times a positive equals a positive. A negative times a positive, or a positive times a negative, is always negative. So positive times a negative is equal to a negative. And a negative times a negative equals a positive. Your learning targets today were I can multiply a positive number with a negative number. This can be helpful with times, positive or negative times, and also direction. And the other learning target is I can use rational numbers to represent speed and direction, which is called velocity. At this time, please make sure that if you are not meeting that learning target, that you go back and review. If you feel like you can meet that learning target, please go ahead and log in to your Go Formative and attempt your cool down.